Class today, we were able to talk about vertical angles and corresponding angles, as well as alternate interior angles. So we recapped with this opening exercise, so we should have these notes from class today. All these pairs of angles that are mentioned are all congruent to one another. So we know the vertical angles can come from any pair of intersecting lines. Alternate interior angles are more on the special side, where there's only 8 and 1 and 5 and 2, because they're inside, interior, but they're alternate sides of the transversal. Remember, R is known as a transversal because it's a line that cuts two parallel lines. And the corresponding angles, it's like 1 and 6, where one's inside, one's outside, but same side. So we should have talked about that. And we were able to explain why angle 1 had to be 47. We had to use parallel lines, and that angles on a line add to 180 degrees. So we needed that. We could have used vertical and alternate interior angles in our responses as well, but this is just the method we did in class today. And we talked about exercise 2 as well. We knew the labeled parts. We knew that angle ABC was 112 and angle EAD was 24. So with that periwinkle color, that's what we started with today in class. And then from there, we were able to use those parallel lines. So see that 24 and 24, those are your alternate interior angles. The Z shape was formed, so we were able to know they're congruent. We also know that this angle here was 68 degrees because 112 and 68 add up to 180. They're angles on a line. And from there, I highlighted this blue triangle. We know triangles also equal 180, so we were able to add 68 plus 24 and then subtract it from 180 degrees to know 88 degrees was that X, which is the angle DAB we were looking for. From this, the two big goals that we got were that when we're proving properties of parallel lines form congruent corresponding angles, or they form parallel, or the parallel lines form congruent alternate interior angles. Anytime we want angles from parallel lines, it's one of those two. And we write it just like that as our reasoning, similar to how we write perpendicular lines form congruent right angles. We were able to finish this last proof, exercise 3. So in the following diagram, M and N are parallel and cut by a straight line transversal. Angles are shown and numbered below. So we want to show that angle 1 and angle 3 are supplementary. So let's start with what we first knew. We knew that M and N are parallel. They are indicated by an arrow. So anytime you have that arrow, it shows that they're parallel. That was our given, which means we could say that 1 and 2 were alternate interior angles. They're congruent. Notice they're along that Z pattern. Okay. We also knew that angles 2 and 3 had to equal 180 because they are on a straight line path. So angles on a line equal 180. Now, we knew that angle 2 had a roll in both places. So since it's equal to 1, I can replace angle 2 with 1 here in step 4 and say that angle 1 plus angle 3 is equal to 180 by substitution. And to finish this off, we should know that supplementary angles are just two angles that add to 180 degrees. So we knew supplementary by this. In the next exercise, we're using parallel to prove that we have congruent triangles. So when we set up our statement and reason, we always start with our given. So in the following diagram, we know that AB is parallel to DC, and I also know that AD is parallel to BC, so I'm going to mark those. So a single arrow for AB and a double arrow for AD and BC because they're not all parallel to each other, similar to how we give like 1 mark or 2 marks to show which parts are congruent to each other. Now, we know the two triangles we're trying to prove. So one thing right off the bat, just from our picture alone, is we should see reflexive. That BD is in both triangles. So BD is congruent to BD. That's our reflexive property. It's an exact overlap in both. Now, let's start with AB and CD. we could see that angles 3 and 4, there are alternate interior angles. I'm sorry, I meant angle 3 and angle 5. And the way we wrote it out before is parallel lines form congruent alternate interior angles. So we know 3 and 4. Right now we have a side and an angle in each. We also know, though, that these lines are parallel, and if they're cut by a transversal, it could be the same transversal that, by the same reasoning, 2 and 4 are congruent. So I could write it out if I wanted to, but I don't need to. I could say angle 2 and angle 4 are congruent because they're alternate interior angles. Now look, we have a side in between two angles. So I can say triangle ABD is congruent to triangle CDB. Angle, side, angle. The side I mentioned, I only talked about one side in the reflexive. So this was the side. There's two angles, but I have to look at how they fall. It's not side, angle, angle, because if I read this, it's this angle, side, angle. So I'm reading it for that one triangle. Same thing, angle, side, angle. So we have to be careful of how we set up our picture, but we do know they're congruent because alternate interior angles. Okay, so that would be the easiest way to prove these triangles. Now last, anytime we're trying to prove an angle or a segment, we're going to attach that to CPCTC, always. But the only way we could use CPCTC is if I have congruent triangles. So remember, I need congruent triangles in order to use it. So the first thing I want to prove still is that we have congruent triangles. So we have ABC is our line segment. We have BD parallel to AE. B is the midpoint. Of AC. And angle 1 is congruent to angle 2. So the only thing I know that's been stated is congruent is angle 1 and angle 2. So I know I have one pair of angles. Okay, now I can either look at the picture or look through and see if there's anything in my given. Well, if I have parallel, I want to look to see. Now that means BD here is parallel to AC. If it helps, I could extend this line because lines go on forever. So the transversal that's running through both of them can either be BE, but I really think the one here at CA is more helpful because then if I label this angle 3 and angle 4, those are corresponding angles. So I'm able to write in angle 3 congruent to angle 4. Now this is similar to how we set it up before. Parallel lines form congruent corresponding angles. So yes, we do have to write that whole thing out to get full credit, but I know I have another angle. And last piece here, if I go back and read, I look for a vocab word, midpoint. Well, that midpoint's going to cut AC in half. So I'm able to say AB is congruent to BC because a midpoint cuts a segment in half. And now I have to be careful Because really, before when I wrote this, I didn't give myself enough space because that angle comes after the side. The side is in between the two angles. So read it down the line like angle, side, angle. So it's got to fall in between. Once I have three pieces, like a side or an angle, triangle, ABE is congruent to triangle BCD by angle, side, angle. And now that we have two triangles congruent, we could finish off our proof because any corresponding angle or side is congruent by CPCTC once we know triangles are congruent. So we use parallel here to help us prove. So we always, once we know lines are parallel, we can draw in and try to see if there's any nice place to use an alternate interior angle or a corresponding angle. In the future, we're also going to use those angles to prove that lines are parallel. Thanks for watching.